That's what we're going to look at. So these are the objectives. IP PDU details. That is the title. Topic objective, explain the IP version 4 and IP version 6 header structure. IP vulnerabilities. Please put your mic on mute, please. Just check your mic. I'm getting an interference there. Just put your mic on mute. The next topic will be on IP vulnerabilities, TCP IP, that's TCP and UDP vulnerabilities. So let us look at the first one, which is the IP PDU, which is the PDU is referred to as protocol data unit. But first of all, I hope many of you were able to know the basics of networking. And in the basics of that networking, which has to do with the networking essentials, if some of you have gone through that program, then I believe you should have the basics. So I just want to mention these two areas, which we call it the OSI model, the TCP IP model. In networking, these are key in terms of communication, in terms of how two devices communicate to each other. So they use a model. It's just like when we speak English, you have the elements that make up a sentence. Okay, you get what we refer to as the verb, the noun, the pronoun, adjective, and so on. So once you have this combination laid down properly, you now have a sentence. So in the communication networking, you need to have those elements that make up what we refer to as the model. So there are two major types of model. The one we call the OSI, which is also referred to as open system interconnection. Then we have the TCP IP, which is referred to as transmission control protocol, and that's transmission control protocol internet protocol model. So let's look at, this is just a picture of the two. The TCP IP model was designed in the 1960s to maintain and explain the transmission of data from one point to the other. Whereas the OSI model is a network concept specifically for explaining the communication and working of data and protocols during the transmission of information. So this, the OSI gives you more detailed information regarding what happened to the data, what nature or what the data is as it moves from one level to the other, how it is being transformed. Okay, so it's much more detailed. So looking at these two models, you have at the top we have what we call application layer, presentation layer, session layer, followed by transport layer, network layer, data link layer, physical layer. Then when you look at the TCP IP model, you have application layer, transport layer, internet layer, network access layer. So when you compare the two, putting them side by side, they have some things that are similar, okay, which are, if you look at the application layer for OSI, for TCP IP model, is a combination of these three elements in OSI, which are application layer, presentation layer, session layer. Then what is similar between these two, you have the transport layer on both sides. Another thing that is also similar, but it's just the name that has changed, is the network layer. In the case of OSI, case of TCP IP model, you have the internet layer. Then when you go down, physical layer, that's on the aspect of, that's the side of OSI. Then when you look at the TCP IP, you have network access layer. So why am I bringing this to you is just for you to get to understand that when it comes to cyber attacks on network, attackers could take advantage of any of these layers to gain access, to destroy, or to steal. So they could take advantage of this layer. So that's the reason why I'm bringing this to you. So in the process of this communication, there's what we refer to as the IP version 4 and IP version 6. The IP version 4 and IP version 6. So if I may ask, let me go back to the class. Let me see if others can hear me. I just want to be sure if you know those things. So what do? You just raise your hand if you know IP version 4 and IP version 6. So let me see your hands if you do. Let me have a thumbs up, or you raise your hand if you do. So do you know IP version 4 and IP version 6? If you do, raise your, just let me have a thumbs up. If you don't, let me have a thumbs down. So I have Ilya Subawa. Yes, he has an idea. How about others? Is there only one person that knows that? That knows the IP version 4 and IP version 6? Okay. So let me repeat again. Paul Blessing, are you with us? Let me have your voice. Okay.
I'm here, sir.
No. Okay. So do you understand the IP version 4 and IP version 6 so that we can move? Tawhid Kasim, how about you? Okay, Blessing, you want to say something? Go ahead and say. Any idea? Okay.
Okay.
Tawhid.
Oh, no, sir,
Okay.
not yet.
Blessing, go ahead.
Not yet.
Not yet?
I said,
wow.
Yes, yes.
Okay. All right. Kasim says he knows, he understands what we mean by IP version 4, IP version 6. How about Edgar? Edgar, are you with us? Do you understand what we mean by IP version 4, IP version 6?
I don't know, sir.
You have an idea? Okay.
No, sir.
Others
I don't
are
know,
silent. Sir. You don't know. Wow. Wow. Okay. So let me see what I can do to see that I'm able to carry you all along in this class. So for communication to happen, let me still go back to this layer. Let's pick the OSI model just to explain what really happened. You have a system, let's say a system A and another system B. These two systems are connected via the wire. You use a network cable to connect them, interconnect them. So this connection, we refer to it as a media. You can use wireless to interconnect these two devices. And wireless, you can have Bluetooth, you can have Wi-Fi, and other technology that are available. So to interconnect these two devices. So by the time, let's assume one of the devices is a server. That's the B is a server. A is your laptop. So from your laptop, you open up your browser. That browser that you open, okay, your browser you've opened, and you now type the address to the server. So what you have initiated this layer, the application layer, and there's a conversion that happens, conversion of the information, whether it's a picture or whatever, all this happen within this layer, a presentation. So that's, you initiate this from your browser. So from your browser, you've initiated the application layer, presentation layer, session layer. That's for on this side. When you look at TCP, what they are dealing with is the application layer. So what you now did is the moment you enter, that data is being converted within this application layer. Then there's what we refer to as transport layer. The data now moves down the ladder before leaving the system, before leaving system A. It moves down this ladder, let's say the OSI model, moves to this, which you call it the transport. So it tries to identify the type of communication that should happen between your laptop and the other. It's just like it's trying to maintain the conversation between your laptop and the server. So when I say conversation, there are so many things that happen behind the scene on your Windows. So there are a lot of communication that happens. So you need to separate those communication. That's a conversation. So this guy, the transport layer, is just to separate. So there's what we refer to as TCP and UDP. So the TCP is the guy in charge of making sure that the communication that is about to happen from point A to point B is reliable. Okay. Then when you are dealing with UDP under the transport layer, is to make sure that the communication that you have that happens between A and B is unreliable. And a good example of unreliable communications are like your streaming, your videos, streaming of a live program. Okay, so so since you are streaming, it doesn't make sure. I mean, it doesn't check the reliability of that information when it moves from one point to the other. So that's the reason why when you are dealing with voice messaging, sometimes when the person is talking, you might miss some certain information while listening. That's the other guy listening. So it's making use of that other type, which you call it the UDP. And it's a protocol. We'll talk about it in later chapter. I mean, within this same module. Then the other one that is reliable is just to make sure that when we say reliable communication, A sends a reliable communication. When B receives it, B has to respond that it has received that communication. Then, there's this form of acknowledgement, which we'll also look at it. So when you move still on the same system, it's just preparing the data. Still on the same system, you have the network. The network layer is what we want to begin with now. The network layer is what these issues of IP address is attached to this information. So attached to this transport layer. Okay. So this IP address is attached to the transport layer. Then everything is now added to what we refer to MAC address. Then from there, the message is now converted to zeros and ones. So once everything is converted to zeros and one, it's now sent down through the cable. It now goes to the other device, which is B. Then the B begins to convert the information from zeros and one back to data link, back to network, back to transport, up to application. That is where the server will now open the message and see the content of what has been sent from the other side. So this process takes place at a very fast rate without you knowing. Okay. So first of all, there's always a system that initiates the discussion. So in the process of initiating that discussion, all these processes happen within this area, which is the application. Then to maintain the conversation, whether it's reliable or unreliable, it happens at this level, which is called the transport. Then there's what we refer to as IP address. An IP address is attached to this information, which is the transport. Okay. Then you also go down. Another form of address is also attached to the where is it? Attached to the network layer. Then at this, that's from here, is attached to the network. Then at this level, everything is converted to zeros and ones. So what I'm just trying to say is what we call encapsulation processes. Encapsulation processes. So let me start again. From here, when you initiate the information, there's an encapsulation that happens. It encapsulates, let's assume this is our data, the whole package. The whole package is not encapsulated by data, by something. You know, when we say capsule, you have a capsule, like the drugs. In the capsule, you have the drugs. So those drugs, the real thing, the content is your data. So you have a capsule. So this guy encapsulates which is your data. Then when it comes to this side, which is the IP address, another form of encapsulation happens, which is the IP address. It goes down the ladder again, another form of encapsulation happens, okay? It finally comes here. The entire encapsulation is now converted to zeros and one and now sent. So when the receiver now gets it, you have the encapsulation process that happens up to the level where the message is now displayed. So where do we use the IP address? How do you know a system has an IP address? There's a command which we call it the CMD, command prompt, CMD. To go to CMD, just go to search box of your Windows, you type CMD or command prompt, command prompt, you type that, okay? So there's another command that you use. That's when you initiate the command prompt, you now type this command, ipconfig, you put a space /all. I hope you can see this. If you can see what I'm just typing, you just say yes.
Yes, sir.
Okay.
Yes, sir.
So you type ipconfig, you put a space, /all. So when you do that, you enter. So want to find out the address. You know, all these things I've been doing, I'm using right now. I'm still operating at the level of application, but I want to go down to look deeper to know what has been assigned to my laptop. My laptop is connected to a wireless network, which is my hotspot, my phone. My phone has has a server. That's every phone with a hotspot will have a server for giving the IP address. So this is where you find the IP address for my like for this case, my laptop address is found here. So first of all, I'm using a wireless connection. This is my wireless connection, wireless LAN adapter Wi-Fi. So that is what I'm connecting to the internet to get to you. So if you go down, there's a place that is written physical. This is physical. So this physical is one of the address, okay, which I'll still take you back to our diagram I showed earlier. Then there's another address again, which is this, which we are talking, which I want to mention. This is it. You can see IP version 4 address. So this is the address that has been assigned to my laptop. So this is the IP version 4 address. Okay. So I won't go deep to this part so that you guys will not get confused. So the reason for this address now is this. Now, there are two main addresses that is assigned to your data, which happens at this level. Before the data will now leave your computer system towards going to the next PC, which is, let's say, computer B. Okay, so there are two main addresses that will be assigned to your data, to the major data, which has been encapsulated. So the IP address happens here, where you see this cursor. It happens here. That IP address you saw, it happens around this area, which is called the network layer. Then there's another address, which I just mentioned. There's another address which happens at this layer, this place, data link. So I had said there are two addresses that will be attached to the data before it leaves the computer. So the two, there is one, data, which happens at this layer. Then there's another one which happens at this layer, which is called the network. So let's go back. What are those addresses? Let's look at them. Where you have the network, this is the address that is used for the network. Okay. Then the other one is this, which I've showed to you. So there are two addresses. Okay. So this address is, we can use this okay, let me say like we humans, we we as humans, we have what? We have our fingerprints. Okay, so your fingerprint, as you move from one state to the other, or you travel from one country to the other, or from one local government to the other, your fingerprint remains the same. It doesn't change. Okay, so that fingerprint does not change. So it's referred to as this. This is your physical. So if I take this, my laptop, to another country, this address will remain the same. And this happens at this layer. It happens at this layer called the data link layer. Okay, it happens at this layer. So let's quickly go back again. So your physical, that's your fingerprint, does not change. If you move from one state to the other, it still remains the same. Then the next address, which is IP version 4 address. The IP version 4 address, right now I'm connected to my hotspot. Okay, it's more of like I am in Nigeria. Okay, and I have an identity as a Nigeria here. So when I leave Nigeria, I go to another country, I'll have a new identity in that for that country. Let's say Ghana. I'll have a new identity in that country called Ghana. Okay, so that is your IP address. So your IP address, as you move from one state to the other, your IP address change. As you move from one network to the other, your IP address changes. So this happens at this layer. It happens at this layer, which is called the network layer. Okay, so in every communication, by the time the information leaves the system, it's being attached to kinds of addresses. And why the two addresses? The data link address is for communication from one device to the other. One device to the other. But what if you have a communication that it has to transit through various devices? Okay, it transits from, okay, let's say you have computer A, you now have another computer B. From that computer B, you have C. Okay, so there you have a connection between these, from A to B, B to C. Now, so when you have a data that needs to go to C, from A to C, it has to pass through B. So where it is important that you now use the IP address is the network. The IP address is useful at this level when it's moving from A going to C. That is where the IP address is being used, from A to C. So IP address takes it to the final destination. But for the MAC address, or the physical address, which we also refer to as the MAC address, it is for the communication point to point, A to B, B to C. That is where that this address is being used. Okay, so I've talked about much on this so that you have a bit of some idea with respect to the IP address. So we have two types of IP address. We have the IP version 4 and the IP version 6. The IP version 4 and IP version 6. And there's a reason why why we have these two versions. The first version, with the number of systems that we're connecting to our network, that version 4 won't be able to accommodate the large number of equipment or the large number of devices that are on our network. Even we use a different method. There's a method to see how we can still accommodate as many systems on the network. We use what we refer to as subnetting. That didn't give a good result. And in terms of future, it will not be enough. So the total number of IP versions 4 address you can have, or so far generated, is 4 billion. 4 billion different addresses are connected to different devices. But there's still what we refer to as subnetting, to still extend these addresses, but still that is not enough. And that's the reason why we now have the IP version 6. So the IP version 6 can take as many systems. So when you do your maths, you say 2 to the power of 128 is a large address space, which means anything in the planet in this world will be able to connect to the network using IP version 6. Okay, so that is it on that. So let's quickly move. We have a long way to go. So I hope from the little explanation, you have an idea now. Let me get the response from you.
Yes, sir.
Yes, sir.
Okay, so what I will encourage you guys to do, still go to our NetAcad platform. I think you should look for Network Essentials. You can self-enroll yourself into that. Look at the curriculum, read through it. Then there are exams too. You can also quizzes and exams you can also attend. At the end of it, you still have a certificate with that. So that gives you a good foundation when it comes to this addressing. So every device that connects to the internet or to a network must have this address, the IP version 4 or the IP version 6. So now this encapsulation, which I've mentioned, the encapsulation, back to this same area. This data, the whole of this is put together. When it goes to the transport layer, is encapsulated. Okay, so the encapsulation name given to it at this level is called that's the PDU. You know, we mentioned something IP PDU earlier. So the PDU at this level is called the protocol. That is the protocol data unit. Is called at this layer is called the segment. Okay, so the information encapsulated. That's this guy encapsulated this data. This guy encapsulated the whole of this guy. So it's called, when they encapsulate it, it's called the segment. Then at this level, this guy encapsulates the whole of this guy. That's the transport and the data above it. So at this level, it's called the packets. Okay, the packets. Then when you go down, this very one, this data link, encapsulate all the information. That's the network, the transport, and other things that you find here is referred to as frame. Okay, frame. That is the PDU name for it. Frame. Then finally, when it reaches this level, everything is converted to zeros and one, because that is what, in terms of electrical communication or signals, those signals are converted to zeros and ones, okay, and now transmitted, whether wireless, whether wired. Okay, so that's what we mean. So this encapsulation process, there's what we refer to as, we call the headers. So this is how the header for the packets, that's for this level, for the packets, the network layer, for the packet. You know, I've said the PDU. The PDU to transport is segment. The PDU here is what? Packet. The PDU here is frame. The PDU here is just bits. That's bits, zeros and one. Bits, that's the name. Okay, so there's what we refer to as header. What the packet carries. Additional information, that's the information it carries. That's the packet when it's been at that level, when it has been encapsulated. So these are the this is how the header looks like. It has so many things around it. Okay, so IP design as layer 3, connectionless protocol. So what we mean by layer 3, anytime you hear the word, let's go back again. I think we'll continue to use this as reference. So when you look at it, when we are comparing it with this guy now, okay, which is a TCP IP model, okay. So when you hear things like layer 1, layer 2, and layer 3. So when we talk about layer 1, we're talking about when you're looking at the TCP IP model, where you see my cursor here. I hope we're together. Hope you can hear me. I just had the...
Yes, sir.
Okay, great.
Yes, sir.
So, all right.
Yes, we can hear you.
So
Yes, sir.
this...
Very
Okay, thank you. So when you look at the TCP IP model on this side now, you will later on, as we move further, you hear things like layer 1, layer 2, layer 3. Okay, there's nothing like layer 4 in networking. It's usually layer 1, layer 2, layer 3. So we're talking about this. So this is our layer 1, network access layer. Layer 2, sorry, it's here, this side, please. Okay, this is it, sorry. It's here, physical layer. This is layer 1. This is layer 2. This is layer 3. Okay, so when you hear layer 3, we're talking about network layer. We're talking about, I'm talking about this guy. This is the OSI model. This is our layer 3. You start from the base again. Layer 1, which is the physical. Layer 2, which is the data link. This is our layer 3. So let's go to our, that's the header. So this is how the header for the packets, this is how it looks like. Okay, why we're bringing this is just for you to prepare you. The threat actors or cyber criminals, whether cyber criminals or threat actors, these guys, they take advantage of some of these things within the packets. Okay, so we'll look at the compositions of what we mean by this. So IP design as a layer 3 connectionless protocol delivers packet from host to destination over an interconnected system of network. So not designed to track and manage the flow of packet. So what we mean is that the layer 3, which is the network, the layer 3 has no it has no concern. Its own is just to forward the packet. It just is at this layer is because apart from the IP address, it has other functions. So the other functions, that's what I'm trying to explain now. So it only forward the information, like let's say it gets the message from one end. Its intention is just to forward to the other direction or to the next device. That is just what this layer 3 is all about. So if required, perform primarily by TCP at layer, okay, sorry, I said there's no layer 4, there's layer 4, please, sorry. If required, perform primarily by TCP at layer 4. So what we mean by tracking, when you are sending data across the network, you need to have somebody who will track. You know, I talked about the TCP, meaning the TCP is reliable. Then we have UDP that is unreliable. The TCP is used, which is much more reliable, to make sure that the data reaches the destination correctly. Then the other one, which is usually used for streaming, it doesn't care, but it just sends the information and reaches the destination. So the TCP have to make sure that it reaches correctly, which happens at this layer, which is referred to as transport layer. So that's where the TCP. So when we are talking about in terms of tracking, it's the TCP that handles that, not the layer 3, which is the network layer. The network does not handle that. It's only just to forward. So IP does not validate whether the source IP address in a packet came from that source. So just like I said, it gets the packet and just forward. It doesn't look behind and say, okay, where is this guy coming from? It doesn't look behind to find out where is this information coming from. Okay, it doesn't look. Its own is just receive and forward. That's just what the layer 3 would do. So IP does not validate whether the source IP address in a packet came from that source. So threat actors can send packet using a spoof source IP address and tamper with other fields in the IP header to carry out their attack. So that is why I'm saying it is important you have a full grasp on this so that you have an idea of what attackers do. They try to take advantage of some certain areas. So in the header, there's a place where you have, there's an area where it says source IP address. So where the data is coming from. So attacker could take advantage of that source, but the layer 3 does not have any, doesn't look at where is it coming from. That's what we're talking about here. So security analysts must understand the different fields in IP version 4 and IP version 6 headers. So it's important when you go into, as you dive into deeper into cybersecurity, you need to understand these headers. So let's look at some of these fields of the header, what they mean. So there's a part of the field, that's this one. That's the header. We're talking about the header. There's an area within the header. It's called the version. Let's go back quickly. So this is where you find the version. This is our version. Where my cursor is, that's the version. So the version, it contains a 4-bit binary value set to 0100 that identifies this as an IP version 4 packet. So this is just binary. So if you convert your binary to decimal, it's 4. Okay, you convert this to decimal, it's 4. So that's how we get the version. Then, excuse me, the next one is internet header length. The internet header length, that's the length of the header, is a 4-bit field containing 20 bytes in minimum length of IP header. Then we have differentiated service or diffserv, DS. The DS field is an 8-bit field used to determine the priority of each packet. When we say priority, so when it comes to like in networking, maybe some of you must have observed this. When you want to browse, you want to go to a site, you discover it's a bit slow. But when you go to like this streaming that we're having right now, you see everything flows, the traffic flows fine. Everything goes fine. So there's a way the system prioritizes such traffic. It prioritizes such traffic. But by the time you say you want to go to, maybe just open your browser, you want to go to a particular site, you may observe there's a delay in that process, trying to fetch the information. So this guy also play a role within that area. So the differentiate service. So he prioritizes the packet that is being transmitted. So the 6 most significant bits of DS field are differentiated service code point DSCP. The last 2 bits are the explicit congestion notification ECN bits. So what they're talking about is still here. Still on the header. That is this. So you have within the header, you have differentiated service DS. So that's the DSCP, and the ESCN is just here. That is just what has been mentioned. Then total length. Total length specify the IP packet length, IP header plus user data. So the length of the header, the IP header, plus your own data that has been packaged. So that is the combination of this. That's the total length. The total length field is 2 bytes. So the maximum size of an IP packet is 65,535 bytes. However, packets are much smaller in practice. So we'll look at those ones. I'm going to use one sniffing tool. It's a software, very, very good software when it comes to cybersecurity. Identification, flag, and fragment offset. As an IP packet moves through the internet, it might need to cross a route that cannot handle the size of the packet. So the packet will be divided or fragmented into smaller packets and reassembled later. These fields fragment and reassemble packets. So this is what these particular fields handle. They fragment these packets as they transit over the network. So you can have a full package, but this full package is not what is being sent across. Everything is broken into fragments. Then at the end of the receiving end, that's the receiving end, everything is reassembled. The other part of it again is the time to live. The time to live, an 8-bit binary limits the lifetime of packet. The packet sender sets the initial time to live value, which is decreased by 1 each time a router processes the packet. So what we mean here is that as the packet moves from one router to the other, maybe the value, let's say the value is 5. So when it goes through a router, passes that router, the value decreases. So if you have 5, it passes that router, it decreases to 4. It goes to the next router, decreases to like that until it reaches 0. So, which decreases by 1 each time a router processes the packet. If the TTL field decrements to 0, the router discards the packet and sends an ICMP time exceeded message to the source IP address. So what we're trying to say, maybe you have observed this. Maybe you're trying to reach a website. You enter this, then after a while, you just get an error message on your page, okay? That the website, maybe the website is not available. Quite okay, you are connected to the internet, but you just get the message, the website is not available. So it's with the help of this. So the essence of why the decrement is that it doesn't want a situation whereby even the website is not available, this data packet continues to circulate over the internet. So it tries to prevent that, to prevent a looping on the internet, because the whole thing can continue to move around the internet forever. So to prevent that is by introducing the TTL. So that it, as it reaches 0, if it doesn't find its way to the destination, the packet is dropped and you get a response back on your system that maybe the web page or the website is not available or things like that. You get an error message. Protocol, it identifies the next level protocol. These 8-bit binary values indicate the data payload type that the packet is carrying, which enables the network layer to pass the data to the appropriate upper layer protocol. What we mean is that the protocol, let's go back to this again. So what we mean is that at this is our network, where all this discussion is at this level now, the network layer. So there's a protocol that is attached to it, information about the protocol. Meaning, let's assume the data arrives the next system, which is 0s and 1s. So from the 0s and 1 is converted to this, which is the frame. You now have the IP address. So within the header, it tells it who is the next person that should receive this information. That's the layer. Which layer should receive the next info? That's the information after the encapsulating. So within is attached the information regarding this layer. But if the information is coming the opposite side too, within the packet, it will gather that information that should pass it to this guy, the data link. So all these are also attached within this as the protocol. Then we have another area called the header checksum. The header checksum calculates value based on the content of the IP header, determines any transmission-induced error. So the data that moves from transit from one point to the other must be correct. Nobody should tamper with it. There's no change should happen. Okay. There's one software. I just want to let me see if I can explain that part quickly. There's one software. You can check it. It's called the hash calculator. Hash calculator. Why that checksum? What happens is just to check the integrity. You could have the same, maybe what you see with your eyes. You may think that everything is correct from one point to the other. Everything is correct, but not known, unknown to you. It's possible an attacker could have changed the information, so the integrity has been compromised. So this site is another tool that I think we are going to look at later on in this program. The hash calculator is just to help us check the integrity of that the data that we are sending. So that happened around this area, which is called the header checksum. Then finally, this area, the source IP address. So for every communication, just like I mentioned earlier, you're sending a data from A to B. From A, which is the sender, B is the receiver. So A is your source. So the A must have an IP address attached to the entire data in terms of encapsulation. B is the receiver. That also will be attached. So you have the source and you have the destination IP address. So usually you have two IP address attached to the packet as it's being transmitted from one point to the other. Then the last one, which is options and padding. This field that varies in length from 0 to a multiple of 32 bits. If the option values are not a multiple of 32 bits, 0 are added or padded to ensure that this field contains a multiple of 32 bits. So, you know, we've heard of things like padding. The padding, there's an area that is useful where it mustn't be 0. So it mustn't be 0 in terms of what has been added to the packet. So it mustn't be 0. So anytime it's 0, it has to be padded with 32 bits. 32 bits will be attached or padded to the packet before it's being transmitted. So there's a video on this, but we're going to look at, let me quickly use a software, which is called the Wireshark, to also explain this area quickly. So let's go to Wireshark. There's a software. Let me start the Wireshark quickly. So you guys, are you with me?
Yes, sir.
Yes,
All right.
Yes, sir.
So the
Wireshark
is a sniffing tool. Is some, like you, the analyst, you need to use that software, and even attackers too can also use the software. It depends on what they are after. So it's a sniffing tool. You can just go to the website or you just search. Just go to your Google search. You type Wireshark download. This is the website. It's wireshark.org. Then you look for the one that is suitable for your system. If it is Windows, you download for Windows. This is the website. So you just download Wireshark for your system. Okay. So this is the site. So I've installed the software. So let me initiate the software so that we'll see what happens. So I'll just type Wireshark. Wireshark. Okay. So I've clicked. So I've initialized this. So as it stands, I'm using a wire connection. I hope this view is okay. How do I increase it? Let me see if I can increase. Okay, I can do here. Anyway, just look at this spot. If you look at where my cursor is, you will notice there's some kind of like a signal. There's a kind of signal. Look closely where it's written Wi-Fi. Since I'm connected to a Wi-Fi, you have this. If you're connected to wired, you have something like, this is my wired connection, which is written Ethernet. If it's Ethernet, you see an information, but I hope you can see something here. There's an activity happen here around this area where you have the Wi-Fi. Sorry, I can't zoom this. Okay, but anyway, let's quickly, without wasting more time. So you can see there's an activity here. So this is telling me I'm connected to a Wi-Fi network. So I'm getting this signal. So want to dive into this area and look at what is going on. So once you select it, first of all, you have to select. Then there's a place at the top right. It says start capturing packets. So I want to capture the packets from my system as a sending to probably another destination somewhere. So I want to capture the packet. So I will start. Then after a while, I will now click stop. Okay. So let me start. I just started that. Okay. See what's going on. Then I'll stop. Okay. See what just happened. It has captured so many packets. Just look at. I'm scrolling up. I'm taking it up. Scrolling up. I've captured so many packets here. See, a lot of packets. Okay, so each of these are packets. each of these are packets. So it has captured so many packets, as you can see. Okay, so what I'm going to do now, I'll run this. I'll open a browser. I will now type an address. Then after I've opened the address, I'll type an address, enter. Then I'll come back here and stop the capturing. So let's do that again. Okay, so let me do that quickly. So let me open my browser. Let's go to a website. Okay, first of all, let's start this. Let's start the capture. Okay, let's say continue without saving. So let's go to a site quickly. So let's go to cisco.com. Let's say cisco.com. Enter. So allow it to load. When it finished, then we'll now go back to our Wireshark and stop. So it has gone to that site. So let's quickly go back to Wireshark and we stop that. Let's stop that here. So we have stopped that. So this is how you capture packets from your system to another website. So at first, when I did that, we saw information, a lot of information. And even when I did the second one by going to a website, it still captures some other information. But mind you, your laptop, as you use your laptop and you connect to the internet, there are other things that without you initiating, especially Windows, there are a lot of packets that are being exchanged between your system and a remote destination. So for like your update, your Windows do some updates. It makes requests from your system to a different location. You have other applications that you install. As you open up your system, you connect to the internet, they are doing something, a lot of things at the background without you knowing. Okay. Some you know that you initialize them, while others is already there. So that is the reason why you have so many things that have been captured. So these are our packets. So these are so many packets. So let's look out for the packet that has to do with going to this site, cisco.com. Let me do something quickly just to be sure of the address that we used. Let's use the command line interface. Let's use the command line interface. So I'm going to issue a command. An easy one is the ping. There's a command, you just say ping, let's say cisco.com. I'm trying to come up with an address. Is it cisco.com? Enter. Okay. So this pinging, we'll talk about the pinging, but it's able to give me something. Okay, let's just cancel it. So this is what I'm interested in, this area. This is what I'm interested in. So I want you to take note of the address. 72. This is an IP address. So 72.163.4.185. What this address stands for, this is the address of Cisco website, Cisco server. Okay. From my system, I'm hitting Cisco server. This is their address. So instead of using this, everything is converted to this format. So this is the address of Cisco website. So I want to locate this on my captured packets. Let's see if you can see this address, 72.163.4.185. So let's check that quickly. Let's come here. Let's see where we can get that address. There are so many packets here, but you can use the filter or you can scroll. Scroll will take you some time. Let's see if you can get that. Okay, let me see if I can use the filter. Okay, let's check the address again. 72. Okay, this is the filter. Let's try the filter and see if we can get that quickly. 72. 72 dot what? Dot 163. Dot 163. Okay. dot what? Dot 163.4 dot 185. We have a lot of filters here. Okay, I think I'm using the wrong command. Let's see if we can do that quickly. Should be here. There's so many. 7 to, I think I'm using the wrong command to get that. Okay, anyway, without wasting much time, there's still a way you can get it. You can still get that. It's just that there are so many traffic for us to search. To take us some time. But anyway, let me just use this just to explain what I'm trying to bring out in the class here. First, let's look at this part. Let me pick one here. There's TCP. Let me start here. TCP. Let me pick one here. Okay, let me just pick this. If you look at where I just clicked on, you will see there's an address. I hope you can see what I just clicked on. There's an address. My system, let me get the IP address of my system again quickly. Let me clear this. So let's say ipconfig, that same command we used earlier, /all, ipconfig/all. This is my IP address. This is my, sorry, here's it. This is my IP address given to me, 192.168.241.61. So we need to locate this, 241.61, yes. Here is it. You can see it here. Let's start from here. You can see it, 192.168.241.61, okay? And it's using a protocol called the UDP. So let's pick the next one. I'm trying to get the one that will be a lot easier to explain here. Is DNS. Okay, let me just use these. Let me pick this. Wow, there's so many. Okay, let me just pick this one. Let me pick this. Okay, let me pick this. There's 192.168.241.61 is going to a destination called, it's a destination which is 104.18.32.47. Hope you can see what I just clicked on. If you can see, just say yes. If you can't, let me know.
Yes.
Okay, so I have this. So if you look at the top, you see it says source and you have destination. Source, destination. Then you have protocol. Then you have other information like length. You have length, you have info. So the source now, there's a particular traffic that is sent from my system to a, that's my system is my source, 192.168.241.61. That is my source. Then it's being sent to a destination, 104.18.32.47. And it's using what? It's using this protocol, the TCP. And I said the TCP happens around what? The transport layer. Okay. So now let's look at the breakdown. This is how you check the breakdown. Once you click a packet, this is a packet. This line is a packet. Once you, I mean, this is a communication. Let's say this is a communication. So once you click that, you come to this area where my cursor is. If you can see my cursor, this is my cursor. Okay. So if you take note, you will see something like transport. After transport, you have internet protocol. After internet protocol, you have Ethernet. Then you have frame. Okay. So you can see the transport transmission control protocol happens at this layer. You can see it here. Then the internet protocol happens at this layer. Then that of the frame, it happens both on this layer, these two. Okay. So now let's break down the internet protocol. Let's click on this. On the internet protocol, those things that I've mentioned to you earlier regarding what? The version, regarding the differentiated services, total length are found in this area. So you can see our version is here. This is for a particular packet, please. This is for a particular packet. You can see the version here. You can see the version is saying version 4. You can see the header length. It's telling us the header length is 20 bytes. You can see the differentiated service field. This is the DSCP, the ECN we've mentioned. You can see it here. The total length here is 52. Okay, that's the total length. That's the header plus the user data. Identification. Time to live is here. The protocol, which one is the next protocol is still the TCP. Okay. Header checksum, you can see it here. Header checksum status, this one is giving a status. Then you can see also source address and destination address. Okay. And when you pick the same, when you pick another packet, usually when there's a communication, when you send a request from your system, the destination respond back with a reply. So let's look at it, which happens here. You see, after this very one, something happened here. So we ignore this. Let's go to where you see the 104.18.32.47, which is here, this next one. So the destination has responded back with the packets. So this packet, you can see the destination. So the destination, the initial destination has now become the source. So it will now become the source. That is the server, the source, and is responding back to our system. So as it's responding back to our system will now become the destination. So you can see the address 104.18.32.47 back to our system, which is this, and is using what? TCP. Well, if you check again, if you check this place, once you click, everything changes. It's not the same thing, please. It's not the same thing. If I click, you see there's a change. If I click here, there's a change as well. Let me go back again. If I click this very first one, you have a change. You come back here, you have another change. So let's take note. The internet protocol here, the version still remains. The header length is still the same thing. Differentiated service is still the same thing. But the total length, I think there's a difference here. The total length here, that's what the server is responding, the data that is responding back. That's the header plus the user. The total here, as it responded, here is now 40. Let's check the initial one. What was it? The initial one was what? Was 52. You can see the initial one, the total length was 52, and the current total length was 40. Okay, so these are some of the things that relates to the header. So with this, I'm able to explain these parts that we just talked about, the header. So let's quickly move on. Don't worry, I'll give you room to ask questions. So the IP version 6 also has its own. Right now, I'm not using the IP version 6. I'm using IP version 4. So if I'm connected to a network that is using IP version 6, they have their own fields, and these are the fields. So they have the version, they have traffic class, which is a bit different from what we have, but you have some similarity with what you have in IP version 4. So the version here is 0110. The traffic class, this 8-bit field equivalent to the IP version 4 differentiated service DS field. That is the traffic field for IP version 4. Version 6. Flow level, you can look at that. The payload, what we saw in the previous one is total length, but here is known as payload length. Okay. Then the next header, which is the next protocol, like what we had in the earlier one, which is the protocol, which is this protocol. Okay. So in this place, is what we refer to as next header. Then the hop limit. The hop limit is also similar to what we have here as the that's the time to leave. Okay, the time to leave. That is the time to leave. This 8-bit field replaces the IP version 4 time to leave field. Okay, that's the hop. Then you have the usual source IP version 6. Then you have destination IP version 4. So this is the IP version 6 packet header. This is how it looks. So you can also use the Wireshark to also dive into to know more about this. Then let's quickly move to IP vulnerabilities. What are those things that are vulnerable to IP packets? That's it. What are those areas that are vulnerable? So the IP attacks, you have what we call ICMP attacks. ICMP attacks, I just did something regarding to ping. The ping sends an echo messages. What we mean by echo, you know, like when you have an environment, maybe a hill, and you shout, hello, everyone. After a while, you get like a reply. That's an echo. You shout, hello, everyone. So when you say hello, everyone, that voice, that sound hits the wall, then reflects back to you. And you feel like somebody is responding, but it's the same you, okay? So that's what we mean by echo. So within the network, you have an echo like that. When you say ping, it's just like I say hello, okay? When you say that hello, you should expect a reply. So when you expect a reply, it means that there's something at the other side of the communication. So that's the this is. So when you say hello, that hello, when it's going, is an ICMP. When it's coming back, it's still an ICMP. So the combination of these two forms what we refer to as ping. So let me quickly show you the ping. So let's ping somewhere. So let's say ping to www.google.com. Okay, you can try that. So when you ping, you should have something like this. Okay, you have this reply, reply, reply. So I'm sending an echo. So when I send this echo, I get 4 replies. And what's it saying here? It says what? The packet that was sent were 4, and the packet that I received as a reflection are 4. So I didn't lose any of the packets. So it means for this communication, the communication was successful. So that hello you are sending is an ICMP. The one you are receiving is still an ICMP. The combination of these two forms what we refer to as the ping. So what do attackers do? Attackers take advantage of ICMP attacks. Threat actors use ICMP echo packet pings to discover subnets and hosts on a protected network to generate denial of service flood attacks and alter host routing tables. So that's what they use the ICMP. It's just to discover the subnet. What is the subnet? We talked about this. I've mentioned the subnet, for instance, quickly. I'm doing this for the sake of those who don't know much here. When you do IP config, you guys are going to use this command too in your assignment. IP config, you come here. You can see this is a subnet mask. This is a subnet, okay? So that's what, so attackers could use this ICMP attack just for them to get some information regarding to the destination. So denial of service, we've mentioned denial of service. Threat actors attempt to prevent legitimate users from accessing information or services. So that is IP vulnerabilities when it comes to IP packets. These are some of the vulnerabilities at this level. You also have this DDoS, that's distributed denial of service. That's similar to DOS, but features a simultaneous coordinated attack from multiple sources machines, which we call them bots. Bots are machines that are infected. Your laptop can be infected. Your laptop can can be a proxy for the attacker. The attacker could be in a location, but he can use your laptop as a proxy. So he has infected your laptop, and the laptop will also help him perform what we call the distributed denial of service. So it's not only your laptop, you can have a group of laptop or clusters of laptop that will be the launching part or the proxies for the attacker. So address spoofing, we've mentioned address spoofing. Somebody can spoof the address of a server so that whoever that is sending the information would think is a server, or somebody who is making a request would think that is dealing with the right server. The man in the middle, we mentioned that in our previous class. Then session hijacking. Threat actors gain access to the physical network and then use man in the middle attack to hijack a session. When we say a session, a conversation that is already happening between probably your server and another computer. So when I say conversation, communication that is already ongoing, that's a session. So a threat actor could hijack. So this is how the ICMP attack works. You have the ICMP carry a diagnostic message report, conditions when routes, hosts, and ports are unavailable. Messages are generated by device when a network error or outage occur. The ping command in a user generates ICMP message echo request used to verify connectivity to the destination. That is the essence of having this. But what does the threat actor look at? What does he take advantage in this area? Threat actors use ICMP for reconnaissance and scanning attacks. Reconnaissance and scanning attack. There's another software that can help you, I think, achieve that. It's called, you can locate for this software. It's called the Nmap. Okay, Nmap is for port scanning. It's another scanner to scan a port. We'll talk about port scanning. Then for other reconnaissance, you can use who is domain lookup. Okay, you can use this. This can also be used for in that process of reconnaissance. Though there are other tools that can be used for this purpose. But we'll come to Nmap. Nmap is a tool for port scanning. Okay, port scanning. So let's quickly come back. So it enables them to launch information gathering attacks to map out a network topology, discover which hosts are active, discover which hosts, when we say hosts, maybe computers that are active and they are reachable. Then they identify the host operating system. So they identify in this process. We have other tools too. We'll come across, we'll look at those tools. Even your labs, you have some tools that will allow you to also do some scans too. Identify the host operating system. Maybe I'm scanning a remote server, so it gives me an idea of what OS that is running, and determine the state of the firewall, whether the firewall is well configured or not. So all these are what the ICMP attacks are. That's the threat actors are after. So threat actors also use ICMP for DOS and DDoS attack as shown in ICMP flood attack in the figure. So ICMP message. So within the ICMP message, there are some areas that are being looked into that you can look at it and see the description. Like for instance, the ICMP echo request and echo reply. This performs host verification and DOS attack. Then ICMP unreachable. We're still talking about the ICMP attack, please. ICMP unreachable. These are the different ICMP messages and what they mean. So you could have when you do your pinging or at a certain level, when you have an ICMP, maybe you get a message like unreachable. This is what it means. When you have ICMP echo request or ICMP echo reply, this is what they mean. When you have ICMP max reply, this is what it means. ICMP redirect, this is what it means. then ICMP router discovery. These are what it means. So let's look at amplification and reflection. This is another attack using the IP vulnerability. The attack, you have the threat actor. This is the threat actor. This is the victim. So this is a router on the internet or on the cloud. So all these are proxies, okay? The proxies, which we call them infected system, called the bots. So this threat actor, through the router, infected all these computers. So these computers will now launch the target. I mean, they will launch the attack to this target. This is the target. So in that process, they overwhelm this target. So this type of attack is called amplification. So threat actors often use amplification and reflection techniques to create DOS attacks. Okay, DOS attack. The example in the figure illustrates how a DOS attack is being done. Guys, are you with me?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
I'm going
Yes,
to
sir.
change the power source. So just give me just some few not up to a minute. I'll be back. Okay, so let me change the power source.